Let's get started. How's everyone? Are we happy this is finally going to be over soon? I am. So next semester I have no teaching. So after this class I will be taking a long break from teaching. Looking forward to it. All right. We will do a review today. Let's put up a few things so everybody knows the time and the location. Just to repeat. Okay, so our exam is scheduled on Thursday, December 15th, quite late, one of the last days, and 12:20 to 2:10, forum 108. So at least when I checked last time on this defective line path, it still says it's forum 108. Is it true for all of us? It's still there? I hope they don't change, because if they change, they won't email me. I'll have to go and check, be responsible, and find out in person. And the other section will be in the same location with us. There will be another one, okay? And I will either email you the day before the exam, or at the day of the exam, when you come to the room on the board, we will write clearly which half will be for me, which half will be for the other professor, so you know where to sit. Is that okay? Okay, so the room is huge. It should accommodate us without any problem. Okay, I want to ask, any of us has conflict with that time? Are we all taking at this time, at least these students that are present here? If you're missing the class, I don't know. Because it's very difficult for me to find that information out. A week ago, we got an email with clear instructions, say there is a web, you can go and you can log in and you can put in, I can put in my Penn State ID and it will pull out the final exam schedule for the courses I'm teaching. And then with a list of student IDs, not student names, that have conflict. I went there and I saw I have 4 conflicts, but then I have no idea where they are going. And then a couple days later, we got another email saying, oh, if you want to find that out, there is a web, you can go, you log in, and then you can put anybody's ID, and you can pull out their schedule. And I was thinking, that sounds like violation of privacy, doesn't it? I think, in fact, it did. And then a couple days later, we got a third email saying now that second email, the website there is now disabled. So now, as current status, there's no way you can find out. So I have to ask in class, anyone? Are we all showing up there? Do I need to make any special arrangement? No? Okay, then I assume it's okay. So, okay, so the room will be divided. And that's okay, and I will we'll let you know how to divide. And then for this final exam, I will do one thing, not to offend anybody. It is actually a common practice by many professors, and we have had many discussions on academic integrity. It has becoming a more and more an issue in the classroom and in the exam, okay, regarding homework, quiz, and exam. So what I will do will be I will take a sheet of paper or 2 sheets of paper, whatever. During the exam, I will walk around, so you write down your name so I know the seating of everyone during this final exam. Is that okay? No offense, just be cooperative, so I have that chart with me, so I know who sit next to who. Okay? Just to let you know, I will do that, so don't be surprised. So seating will be recorded. All right. Okay. There is the study guide on Canvas. I hope you have all looked at it. So we have 110 minutes, right? And there will be 10 problems. And each one will be 7 points, which will give you a total 70 points. 70 points will be 100%. Okay, so everybody knows how heavy this will count towards your final grade. It's all in the syllabus, right? So this will go towards a 30%, quite a big chunk of your final grade. Okay, so right now, I will have 4 recorded grades after some computation. One will be your homework grades, and then exam 1, exam 2, and final. So homework counts 30%. The 2 midterms each counts 20%, right? So I will just export all the grade to a spreadsheet, and what I will do will be, even though this is 70%, eventually I will compute the percentage of your grade. Say for the final, I'll compute your percentage, and then that percentage will be multiplied by 30%. And then your exam 1 and exam 2 percentage each will be multiplied by 20%, and your homework as a percentage grade will be multiplied by 30%, and all those 4 numbers will be added up. And that final number will be the one I will use to do cutoff and give you your letter grade. Is that clear? It's a very simple formula. In spreadsheet, I can just put in the formula and we'll compute all the columns. It's very easy. Okay, that's what I will do. And then there is the question of all these bonus points. Many of us have collected quite a few, some bonus points through pointing out mistakes in the answer, mistakes in the book, and by doing the bonus problem. There's a bonus problem, do that. That will go there also. Okay, so right now my plan is this will go into the category of these homework grades, but we'll see how the whole class perform in the end. So, so for your homework, we had 12 homeworks. I will drop the lowest 2, and then all the grades will be added up. And then I will add all these bonus on top, and then divided by the total points. So many of you will get more than 100% there. That's totally possible. That will go towards 30% towards the final. Quite a big weight there. Okay? Is that clear? Okay, so don't miss the bonus homework problem. Make sure you do that, and that is a nice chunk of points you can earn there. All right. Okay, that's that. And then about final exam. So I have decided to do a closed book final exam, meaning you cannot bring any textbooks, any lecture notes, any prepared formula sheets. No, we don't do that. Okay, bring your beautiful brain. That's what you need. You don't need LP assistance. Everything will be conceptual. All the numbers will be pretty small. The calculator won't help you either. But your understanding of the material, that will be the key point. Is that okay? That's all you need. Yeah?
Do you have a limit for bonus points?
No, no limits. Oh, I know I said 20 points. No, you can go above that. It's no problem. Yeah. Yeah. Yeah, is that okay? Okay, so closed book, which is good. And I looked through the whole book as I was making the final exam, and actually there's only one annoying formula in the sensitivity analysis, right, in the second chapter. So I will tell you that some formulas I will give you, some formulas will be given. I will put them in the exam, and then you will see them. I'll talk about it later, exactly what I will give you. But otherwise, I don't allow you to bring anything else. And so you should bring your ID, and you should bring something to write, pen or pencil, right? Depends on, well, you know what it depends on. And I will bring scrap paper, okay? So I bring scrap paper. And then I don't think scrap papers are very useful because usually there's enough space for you to work out everything. Okay, but I will do that. Okay. Right. So what else do I have to say about these logistics? Any question you have in your mind so far? And then we'll go into a review and talk about details. How about office hours next week? That would be desirable. So in the other class, office hour next week, this is what I set up. I will have some extra office hours on Monday and on Wednesday. I'm not available on Tuesday, so each day I give two, one in the morning and one in the afternoon. Is that okay? And it's the same for 2 days, for both days. Okay? Will that work for most of us? At least you can find one of the time that you can come. If you have questions. Okay. Okay, now let's go into some details of, okay, so some details. An overview first, and then we'll go into more details. So final exam will be comprehensive, so which is a bit challenging. But the focus will be on the last 1/3. Okay, so let's list here. I have part 1 and part 2, which we already had an exam on. So right now, the distribution of these problems will be like, for those two, I will have from 3 to 4 problems. Maybe 3, maybe 4, because some problems you can use stuff you learned earlier or later, depending on whichever method you use. So it's hard to categorize what that is. And then for part 3, we'll have 6 to 7 problems. Is that okay? I was giving a lot of details in the other class, and I should have recorded that class now. Now I might be forgetting something. Okay, so that's a very, very, very brief overview, and then let's take a closer look at each part. So for part 1 and 2, I know we had the exam already. Exam 1, the first 1/3 of the course was like introduction or just very easy stuff, right? Set up the model and blah, blah, blah. Okay. I will tell you that the first 3, among the first 3, 4 problems, actually, the first problem, it will be a true or false problem. There is one problem like that. We had a taste of it in exam 2. Maybe not our favorite type of problem. It's amazing. It's all conceptual, right? If you understand, you know if it's true or false. And if it's unclear, then you don't know, right? So there'll be one problem, actually 7 statements, just like in the exam. So you tell me no reasons, just for true or false, just tell me that. Okay. So I looked at the exam 2, and actually the score for that problem has high correlation to your final score. So this is really a very good indicator of how clear the concepts are in your head. Okay, so one statement. So this could cover part 1, part 2, or also go to part 3. So this question is just comprehensive, just statements. Is that okay? Of everything. Okay, and then for the other, it's a really big part to review. So to make your life easier, let's say we focus on 3 topics. Is that okay? So the review will be simpler. Otherwise, it's really scary of how much you have to review. So we'll focus on the most important things. So first, the simplex algorithm. That's like the big thing. That's the main thing we learned, an algorithm to solve linear programming problem. You have to know how it works and when to conclude, how to pivot, what is a pivoting, or whatever. Just the basic algorithm, you know, where to choose to pivot, or what does it mean, how do you find a basic feasible solution from the tableau, or whatever, just basic things. Is that okay? That's that. So basic algorithm you need to know, and the basic results there. Okay. And what comes next? So I will skip the convexity part. We had fun with it. We had fun with it in the exam 2. If you thought that was fun, we're done with it. I'm not going to pour that out. So, but what is really important after that and connects to the 3rd part of the course was the duality. Is that right? And later on, we learned a dual simplex method. It's exactly based on the duality property. So that we will be tested again. Okay, so you will need to know, so this will be the chapter, is it 5.4, 4.4? Let me see. Let me quote the numbers correctly. I think it's 4.4. Yeah, 4.4, the duality. So chapter 4.4. So there are, maybe in the class I went through in a slightly different way. I call them corollary lemma or theorem or whatever. The book just called theorem and corollary. You have to know the results, all the statements of the theorem and what they mean. Okay, the statements of the theorems there. There are 3 theorems, and there are 4 corollaries. Okay, there are 4 of them. Make sure you know what they're saying, and use the duality theorem for problems. Okay, and another one to focus on, connecting to duality theorem, actually is one of the corollary coming from there, is the slackness theorem. Okay, you need to know. Basically, there's not really a theorem there. It's a fact that we use 2 applications, and it's so useful that with that in mind, you can easily take a feasible basic solution without solving the problem. You can use this to verify if it's optimal or not, right? Because at optimal point, there's so many relations, so many identities you have there based from that. It gives you tons of information, all right? So that's, you should focus on for the first 2/3. Is that useful? Catherine? Yeah, I was about to say that. What would you like? No proof? Okay, no proof. No proof. Okay, everybody happy? You only need to know the results and how to apply them. Yeah. Is that okay? Mm-hmm. Yeah. So some of you are happy, maybe most of you are happy, no proof. Maybe someone's not happy, someone likes proof and say, why I cannot show off my proving skill. All right. And then let's go through a review of part 3, which is the main part. And we haven't had any experience of what problems to come in the final exam. Okay, so you could review the exam midterm 2 we had and check related problems, see how those can be asked on duality or on slackness, and some homework problems from those chapters and examples. Okay, so part 3, we covered 3 chapters, right? Chapter 5 on sensibility analysis, chapter 6 integer programming, and the final one, the transportation problem. So let's just give a rough overview. So there are many sub-chapters, and I would have only 6 to 7 questions. So not all of them will be covered. So I will just write these down, and then I will highlight those that will have a question in the final. I think I'm telling you too much. I should just say whatever I taught in the class subject to the exam. Okay, those are the chapters we cover. And then I'll go into more details. Okay, so right now I just want to highlight some. So 5.1 we already covered in the exam 2, actually. I gave the hardest problem there. That was the toughest one. But many of us did really an awesome job. So yeah. So I have to say, many of you really impressed me by your homework by the second exam. Okay, so good work. Don't feel bad you messed with a proof or not. It doesn't really matter. Okay. So here actually is the theoretical part for all the rest, right? We put it in matrix form and we derive that formula, right? Okay, I'll go into more details. The formula will be given. So there'll be a problem from there. And then 5.3 is change in the objective function. I will give a question there. 5.4 is, there are so many things. They make a change and see some are really not necessary. Adding a new variable. Okay, let's say we cross this out. I will not check you on that. 5.5, change of the b, the constant term. There will be a problem over there. And 5.6, that is important. That's the dual simplex method we introduced there, right? It's a new method, so there will be a problem there, and I will talk details about it. And then 5.7 is adding a new constraint using the dual simplex method to solve. And this actually later on is used in integer programming because we keep adding new constraints to cut the feasible region smaller, right? So it's actually connected to that. So I will not ask directly that, and then it will be embedded in the next chapter. Is that okay? Just to make it a bit easier for you to review. All right, so that's that. And chapter 6, 6.3 is cutting plane. I will give you a question there. And branch and bound. Okay, I know you're wondering what will I ask there. I will specify. And then 7.1 is the distribution problem. There will be a question for capacity, only capacity, take these 2 extreme cases, only for that, a bit easier, all right? Either there's infinite capacity or there's no connection, that one. And 7.2, well, it's such a long algorithm. I'm not able to come up with anything that you can answer in 10 minutes. So I will not ask anything in the exam, but there's the bonus homework. Is that right? If you want bonus point, the algorithm is explained in the final lecture on Tuesday, and you can apply just for fun to see how it's being carried out, and you get some bonus points for that. Is that okay? But I will not test you on the final. Right? Is it clear? Okay, let's go into more detail. That's just a landscape. Okay, more details. If you have any questions come to your mind, ask me. Okay, so let's look at 5.2. Now over there, it's the matrix representation, and then there is a bunch of formula being proved. Those are not so easy to memorize. So I'm telling you, that bunch of formula will be provided. It will be printed in your exam, okay? And it will be printed without explanation. So you have to know what it's talking about. You have to know how to use it. Is that okay? I will tell you exactly what will be printed. This I will give you. Okay, so this will be provided in the exam, just those 4 formulas. But I will not explain to you what is B, what is CB, where you find all these things. You have to know how to do that. Is that okay? That is the core thing for everything in chapter 5, actually. This is all that's needed. And then you know also that this is just A star, and this is just B star. You can easily see that. Okay? So here, if you solve a problem by simplex method, starting from the canonical form until you find the optimal solution, and then given the tableau, you can extract all these informations, the B and the CB and all that. And then one can make a change anywhere and to see how the final answer responds to it, all based on these formula. Is that right? We use them over and over in chapter 5. So with that provided, hopefully it will at least give you a starting point for these problems, a correct starting point. If you memorize the formula wrong, then you can never get it right. Okay? Okay, so that will be given for that. And then there, I will not ask you to prove this formula. I will ask you to use these formulas, okay? And you can see the homework problems in that part. Okay, so 5.3. Yeah, okay, so let's see, change in the objective function. So a typical thing that could be asked here will be, okay, there's a problem that's already solved, giving you the tableau. And then let's say Ci in front of Xi is now changed. Let's say I add some amount onto it. And we've done this in the homework problem. So can you find the range of this lambda so that the optimal solution point is not changed? Is that right? We have done that, okay? And then the way you solve it will heavily, how do you solve it will depend on if this coefficient in front of this variable is basic variable or not. Okay? If it's not a basic variable, it's a simpler computation. That is, you usually get just a one-sided inequality for it. If it is a basic variable, then you have a bunch of them. It will get more involving. It will have more work. Is that right? And once you solved that, and then you can find out the change in your optimal value caused by the change of this lambda. And then there is this concept of shadow price. But I will not test you on that, but I'm just telling you all these concepts actually are there when you do this work. Okay. So so in the example in the textbook and all that we have done, we restrict our constraint into 2 is because that the B matrix in that case will be 2 by 2, and to compute the B inverse, we know how to do it, right? And what I want to say here is actually you don't need to invert the B, okay? You can actually find the B inverse in the tableau. We'll take an example. If I have time, I plan to do that. Okay? And that procedure applies to even problem with 3 constraint or 4 constraint. Actually, the B inverse is already hidden there. You just need to know where to get it. Okay? It's all there. Right. So I'll give you an example on that. Okay. I think I probably did not highlight it when I taught the subject. So now I will tell you that, and it will make your exam probably easier, so you can find that. Okay, so 5.5, change in the constant term in this B vector. So if I change something in the B vector, how does it change the final solution? This, to my opinion, is a much easier thing to do than here. Here you have quite a lot to keep track of. Here, all you need is this formula. Is that right? How would the B change responding to that? Well, B inverse times that. That's the B column in the final tableau. And if it remains positive, then the optimal solution point remains unchanged. It's a very simple one. Is that right? Do we agree? So this is, we'll just comment on that. This is simpler. Okay, so I hope you can do that. So I already made the final exam, so I know what I have to say today. I think it's not hard. It's easier than, well, I don't know. I don't think it's hard, but don't let that sentence put you off guard. Take it seriously. It's comprehensive. It has so much stuff in it. Still do a solid review, all right? But don't be scared. You can handle all of these, okay? Okay, so 5.6. That is an important chapter because we have a new method, dual simplex method. It's slightly different from the regular simplex method, right? The algorithm is different. You check where's negative in the B, and you check the row for where you pivot. Is that right? So you have to know all these concepts. So what is the algorithm, how it works, the algorithm, how it works, and how to pivot, meaning where to pivot, and what to, and then once I give you a tableau, I say, can you conclude what conclusion you can make from a given tableau? So since LP assistant would not be available during the exam, so I will have to provide them. I'll print them out on the exam, as we did for exam 1. You remember in exam 1, the last problem, I gave you different tableaus and asked you to make a conclusion. Is that right? We remember? So it will be like in that direction, and I will add a new feature to it that is, I give you a tableau that is computed, but then I will take away some spots. They'll be blank. I will ask you to fill in the blanks. Is that okay? So So just to let you know what to expect so you don't freak out. Fill in the blanks. That will be a new feature. So in the Tableau, and some numbers will not be there, and you have to put in the correct numbers. The only thing this will be testing you will be the pivoting process. So I need to know that you understand not only where to click, and you also know after you click what it does. All right? So pivoting process. This will be checked by asking you to fill the blanks. Is that okay? Mm-hmm. So I will say here, computational tableau plural, tableaus will be given. Okay, they will be given, and then you try to do these work. Is that okay? Mm-hmm. All right. Now, chapter 6. Okay, 6.1, 6.2. Forget about that. They're just reading stuff. 6.3. Cutting plane. Now, that is a nice method, and it's also graphic, right? You can see in the graph of the feasible region how you make it smaller and cut it off, and to force you to find the optimal solution that has integer coordinates. Is that right? So we talk about pure integer problems. All the coefficients are integer. Okay. So, so you need to know how the algorithm works. You need to know that. So, meaning how to form a new constraint. Is that right? How to cut. Well, basically, you have to know how to cut. Meaning, that is, how to form a new constraint to add to the problem. And if you remember that algorithm, to form a new constraint, you pick a row and you look at all the coefficients and you take out the fractional part of these, right? So there is one possible pitfall that you can make mistake is that. So be careful, be very careful, okay, with if those coefficients are negative. Okay? You know what I'm saying? If it's negative, how do you take the fractional part out of it? It's not what appears there. It's something else. The fractional part is always between 0 and 1. So let's take an example. If I shall have a -3 and 1/10, how would I find its fractional part? Is it 1/10? It's not, right? I want to write this as the sum of an integer plus a fraction, where the fraction is between 0 and 1. So then I will write -4 plus the fraction 9/10. Is that right? And now this part becomes the fractional part. That's the one that will go into your constraint in that formula. Is that okay? I'll just highlight it again because I see that many students can get confused there and get it wrong. Okay, and then we need to understand graphs to illustrate the cut. So you can find the new constraint, and then you can interpret it back into the graph for small problems with two variables, that you can see that this new constraint cuts off something. Okay, you'll be able to. We've done quite a few homework problems like that, right? Okay. Is that okay? 6.4. All right. branch and bound. Well, that's a hard one to come up with questions. Because if you really want to solve a problem with branch and bound, you have to have LP assistant, and it takes a long time, nothing within 10 minutes. Is that right? So I want you to understand how to do it, meaning concepts. Usually it's always concepts that will be checked, meaning how to branch out. If I give you a partial diagram, 2 steps, and it's there, look at this, what will be the next step? You have a choice, you have 2 of those branches. Which one would you pick to further branch out? And what new constraints will you put on each branch to form 2 new problems? Is that clear? And then also, with the computation that is already given there, and how do you form your bound? This would tell you already the optimal solution shall be bounded by something, something, something. When you look at the diagram, you will see that. You should be able to read it. Okay? And then also, probably it's finished. You should already have an optimal solution, right? So how to conclude? And you say, okay, that one is the optimal, but then you have to give me a reason why. Okay? So these things. So it's all. So what I will give you will be partial, just a diagram, and then you tell me. Okay? Either for the branch, or you say it's optimal, or you tell me what the bound will be. Something like that. Is that okay? You don't have to do any actual computation. You just be the mastermind and say what to do next. All right? Is it okay? Okay, 7.1. Distribution. So I will say that here we'll have only with the capacity is either not connected or infinite, and the computation will be easier. And I think the problem, I forgot exactly the dimension I put there. Let's say not too big, but it's more than 2 times 3. I know in the class I did 3 examples, 2 times 3, just to cheat out of it. We can take another example today for a bigger system, okay? So let's say either 3 times 4 or 4 times 5. It will not be bigger than that. Is that okay? Question?
When you go over that today, can you explain again how you know what row and column you get stuck in?
Okay. Should I make you really happy? That problem has a solution. It's not stuck. Okay. Because it will be a nightmare for me to grade if it gets stuck and you come up with all different, I'm stuck here, I'm stuck there, and I don't know what to do. All right. Too much hints. Okay, so that's a lot more details. So does it make us feel more comfortable going to the exam, knowing what to expect? Yeah. We still have half an hour. I can probably go through 2 examples. Nobody give me feedback of what you want me to go through, so I got to pick. Is that okay? So I was thinking, take an example here, bigger, not 2 by 3. That's so easy. And well, these are all conceptual, actually, not hard at all. And that's also pretty easy. I think the thing that will involve more work will be something here, and then we take an example there. Will that be okay? I think the rest is all simple, but okay. I cannot judge it, but okay. So what should I erase? Okay, let's erase from here and take 2 examples. Okay, where am I? So 5.3, we'll take an example from there. Example for 5.3. Okay, so I would also tell you how to find the B inverse from the tableau. You don't need to invert it at all. It's all there, given to you. So for this problem, what will be given to you would be the problem and the initial tableau and the final tableau, okay, using simplex method. So let me set up one problem here just to do. So x1, x2, x3, x4, x5. It takes time for me to copy this number down, but okay. It's not easy to come up with numbers that after pivoting they will remain nice. Usually they get into horrible fractions and it's a nightmare to copy them. So that's the initial tableau for a problem, let's say, okay? And then you have the final tableau, which is down here. Let's say x5 and x1. Let's say 0, 1, a half, 1/6, -1/4, -1/4, 7/2, 3/2, 1, 0, 6, 1, 0, 1/6, 3/4, 5/2, 0, -14. Okay. So that was for the original problem. And now we want to make a change. We want to make a change of this number here. This is the number we're going to change. 5 is going to be changed. I will add or subtract something onto it. And I want to see how does this affect the final solution. So the question will be, can I find the range for this lambda such that the optimal solution point is unchanged? Okay, we have done this in the homework, right? So, okay, so and this formula will be given to you. So you need to know basically how to find B and how to find B inverse and how to find this vector CB, and then the rest, all these ABs are given in the tableau. Is that right? So that is the only thing you actually need to work on. So let me see how to find this vector B. So B is found in the original initial tableau, but using information of the basic variable in the final tableau. You need to take out columns of this A matrix to form this B. Is that right? And you have to be careful. The columns must be taken in the order of these index of the basic variable. If x5 comes first right there, then the first column you take is the fifth column. Is that clear? Don't get that wrong, okay? And then there's the first column. So that will be the B, okay? If I go to the A matrix and figure that out, 5, fifth column is 2, 3, first column is -6, -3. That will be the B. That's where you find it. Is that clear? And then how do you find B inverse? Or you can go and invert it. It's a 2 by 2 matrix, not too bad. But if the problem shall be, let's say, if I put 3 constraints, well, I will not put to you, but if there shall be 3 constraints or 4 constraints, and you start from a canonical form and you pivot it and you reach the final solution, say that's the situation. So how can you find the inverse of B? B will be 3 by 3 matrix or 4 by 4. It might not be that obvious to invert, right? But actually, you don't need to do that because it's in the tableau. So this is in the final tableau. So where do you look for it? You look at the final tableau where these coefficients are called A star, and then you find the column with index that's following the basic variable in the initial tableau. Okay? So that means you take the third column, and then you would take the second column there. So if I go here, the third column here is -1/4, -1/4, and the second column here is 1/2 and 1/6. That's the B inverse. It works for any number of equations following that. You can always find the inverse of B in the final tableau. Is that okay? So you don't have to invert it, all right? Makes it quicker in the exam because, okay, you need to save time. All right, so with that, and then what is CB? CB will be x5, x1. So be very careful. x5 is -2. For x1 is 5. So you actually have -2 and 5. So be very careful. Not 5, -2, okay? It's the other way around. You have to follow this ordering. It matters. Okay, now let's say 5 is changed to 5 plus lambda. So all I need is this formula. That's it, actually. Nothing more than that. And you just need to do that computation, isn't it? So what will be the formula? It's this formula that I need, right? I already know my B inverse. B inverse times A, I actually already know. It's just here. So the C star will be C minus CB. Okay, maybe I don't copy it. I'll just write out. So what is the C? C is this, but 5 is changed into 5 plus lambda. So let me copy the original C first. 3, -2. And I add on top my change. I add lambda on the first one. That's the C. Minus CB. CB is here, and it's -2. And the 5 plus lambda. Is that right? 5 plus lambda. Okay? Times that is just A inverse. Not A inverse, A star. Is that right? So actually the second term here can be opened up into, let me write it like this. So it will be this one times A star minus the thing I add on top, 0 lambda with A star. That's the change I make. Is that right? So you know this part is before I add lambda, and this part over here, and this part is where I add the lambda, the change it causes. So you know this part is without lambda, is unchanged. Actually, you can get all that from the tableau. It will be just this number here, right? That's how you get it. That's how it's being computed. So I have 1 over 6, 3 over 4, 5 over 2, and 0. Okay, and then all I need to compute is this one and that one. Now, this now becomes extremely simple because you have 0 on one and lambda on the second. 0 will be multiplying the first row of A star. Lambda will be multiplying the second row. So all you need to do is take the second row and multiply it by lambda. Is that right? And it's going to be subtracted. And then you know the first one becomes lambda, and it will always cancel that lambda that you have there. Is that clear? Okay, let me write a step. So I have lambda 0, 0, 0, 0. And this computation just gives me negative. And then I copy the second row there and multiply by lambda. So lambda, 1/6 lambda, and -1/4 lambda, and 3 over 2 lambda, and 0. Is that okay? Now I add 3 vectors up. So you know the first one has to be 0 because it's a basic variable. And the second one gets me 1/6. It's minus here, so minus 1/6 lambda. 3 over 4. I get a plus 1 over 4 lambda, and 5 over 2. Again, minus 3 over 2 lambda, and 0. That's what you get. So you have to have 0 here and 0 here, because those are the two basic variables. Otherwise, you did something wrong. And then go back and check, all right? And then what do you have to say? They have to all be positive. Is that right? Let's just finish this. So you have to say, need, require C star to be bigger than 0. So I have 3 constraints coming from those 3 numbers, 3 entrants. So, and 5 over 2 minus 3 over 2 lambda bigger than 0. So all these must be satisfied. Is that right? Just checking my time. Okay. I have time to finish the last one, don't worry. So this gives me lambda less than 1. This gives me lambda bigger than -3. This gives me lambda less than 5 over 3. And then you find the intersection of these 3 constraints. Yep. Yeah.
The first term on the last line in the bottom, why isn't that 0, -2 lambda?
This 0? Yeah. Oh, it's because this lambda minus that lambda. Oh, that's a plus. I got a wrong sign. Sorry. I copied this plus down, it turned into negative. Yeah. It has to be 0. I know it has to be 0, so I didn't even look at it. Okay. Sorry. Okay, now let's find the upper bound. 1, 5 over 3, so it's bounded by 1 on the top, and bounded by below by -3, so you put lambda in between. And that's the range. Is that right? And then you're supposed to find also the optimal value after you make the change, z not star. Well, we have the formula there. This is z naught, sorry, z naught star. You could use that formula, or you could also use the shadow price. Okay, if you use that formula, you just plug in z naught is -21, CB is here, and that's the B star, and you can work it out. Or you can also view this, you know, the shadow price, the solution of this one, right? So how do you say that? You make a change here. Okay, let's don't get too fancy. Okay, let's stick to that, to the first one. Then I'll talk about it. So -21 minus my CB now will be -2, 5 plus lambda. Is that right? Times B star, which is 6, 1. Okay, and you know that's the shadow price actually. So let's work this out, and then you will see what I mean. So 21 minus, if I do this multiplication, I get -12 plus 5 plus lambda. This is multiplied by 1. And you see, if you add up all the integer part, it should exactly equal this number, because that's how you compute that number. And then the only new thing is this lambda you added, and which is multiplied by -1. So, okay, so you could also do copy the last number there, and do 0 lambda multiply with 6, 1. That will end up here with a negative sign in the front. Is that okay? Yeah, but okay, it's not a bad computation. You can also do like that. Is that okay? So this probably is involve much more work than the other part of chapter 5, which will be easier. Is that okay? Okay, let's go to the distribution problem. Let's get an example. distribution. So last example, 7.1. All right, I'm going to draw, this is a 4 times 6 example. And you see it's not bad at all, okay? So don't feel bad about it. It's not bad at all. Let's draw. The table gets a bit big. 1, 2, 3, 4. Okay, so, and I need 6. So let's see. 1, 2, 3, 4. Of course, not long enough. 5, 6. So let me add a bit, just a bit. Okay, so let me put the capacity, that is either infinity or 0. Okay, so that's the 4 times 6, and then let's put the supply. 31, 23, 17, 29, and down here I have 21, 12, 24, 9, 18, 15. Okay, let's go to our favorite color-coded procedure. Green, is it okay? Next one is green. Okay, so we need to set up an initial schedule. Then we'll try to adjust. Is that right? Okay, so let's go through this, and you'll see it's actually pretty fast. It doesn't involve, it's not that bad. So okay, so look at the first one. 21, 31, so I take 21. It's taken, so there's nothing left for that guy, right? This chalk is irritating. And then, okay, so nothing here. So here, 31, 21 is 10, 24, so I take 10. Then this is all used up, and there's nothing. Is okay? Now look at the second row. Here, I have 12 and 23, and let's take 12, and then used up, nothing here. Okay? And now let's look at this one. I have 23 minus 12, which is 11, but this is a 9, so I can only take 9. So it's all used up, and that's 0. Is okay? And then over here, I have 20. I have 2 left from 23. That's 18. So that's going to be 2. So I know the first and the second, no surplus, is all used up. Okay. Now let's look at the third row. So I have 24 here. (24 minus 10 is 14, and the 17, so 14 is what I put. And then this is all met, the demand. And let's go over here, bless you. So 14 minus, 17 minus 14 is 3, so I can put 3 here. And then there's nothing, so this is 5. I actually have 13 units of unmet demand down there, right? Okay, and then this 17 is all used up, and there's nothing here. And then I see I have 15 unmet demand down there. Is that okay? And then already in the computation, you put that 0. You know these 3 has no surplus. The only one with surplus is this one. That's the initial graph. Is that okay? And now you need to do some adjustments. So let's try. Let's try to do, first adjustment is red. Adjustment 1. Okay. So if some adjustments are obvious that you see, don't go through the labeling process. That is very long. So usually you would go, let's say I want to fill here, and usually you know you can use this one to help by the way you do the initial one. If I could ship 15 units here somehow, so I have surplus. Usually you will go to the beginning because there usually you have 0 because you first meet all the demand there and then that's 0. Is that right? So that gives you room to adjust. You see, okay, I need to do 15 units to column 6. So if I ship 15 units, add 15 here, subtract 15 here, I can add 15 here, and then I'm done. Do we see? I bring it to this column. So let's do that. So I'll ship 15 units out. This reduced down to 6, and then this will be added to 15, and then this is done. Okay? That's the first adjustment. Now let's look at the second adjustment, which is adjustment 2, which I do in blue. Okay, now I only need to deal with column 5. And for column 5, the only places I could increase are here. And this could help that, but there's nothing you can do here. So this, maybe it's a good place to do. So let's say if I ship something out here, I reduce this by a certain number. I add some number here. Then I can reduce some number here, and the maximum is bounded by 9. And then I increase here, and then I bring things in that column. Is that right? So I see I can do 9 units to go through, so which means I will increase this. I'll send 9 units from that warehouse, and then this reduced down to 0, and that goes up to 11. Then I have only 4 left. Is that okay? So I want to say that the feasible solution is not unique. The way you adjust is not unique. You can do many different ways, and you can end up with a different solution. Okay? There are many feasible solutions that will all satisfy all the constraints. All right? It's not unique. Okay? So don't worry that you get a different answer, because it's very likely you will. Okay? So yellow, final color. Let's say if I can finally complete by, I have 4 units to ship to here. So how can I do it? I see that if I ship 4 units here, I can use this to adjust. Then I can use this to adjust. And then I can use this, and I can use this. And I see a link. Do we see? Let's say, so that was what I spotted. So, okay, so what did I spot? Let's say I ship out 4 more units. So this becomes 19, and I take away 4. That becomes 2. And then, was it here I said? I add 4, 14. I decrease 4, 10. And I add 4, 7. And then that's down to 0. So I found a feasible solution. You might find a different one if you carry out a different flow of adjustment. Is that clear? So, you see. Feasible schedule found. Okay? But be careful, it's not unique. You might not find exactly the same one as I found. There are others. All right? So, what do you think? Is it bad, this 3 adjustments? It's not bad, right? It's okay. All right. You think you can handle it? There'll be something like this. Feasible. I tell you already that it's feasible. You have to find a schedule for me. Okay? Okay, any questions? All right, if I don't see you at the extra office hour, then happy studying and good luck. I'll see you at the exam. All right?